Okay, let's think back through the years about some formulas that we've used and accumulated over time. So, rectangle. And I'm going to label it. I'll call this the length, and I'll call this the width. Immediately then, I know that the area is length by width. We already did it. And the perimeter, or the distance around the outside of this thing, is an L plus an L plus a W plus a W, or 2 lengths in addition to 2 widths. Okay, rectangular prism. I like to call this shoebox, hat box, whatever. Sometimes people keep their photos in these boxes. Let's see. Okay, I'm gonna label this like crazy. Okay, if I treat it more like this, then this would be the length, and that means this would be the same as length, and this would be a length. And I'm actually gonna call how tall it is the height. So I'm gonna call that a height, but that would mean that this is a height, and this is how tall it is, a height. And that third dimension, I'm going to call the width. So that means this would be a width, and that this would also be a width. Okay, I just labeled every single piece of this. All right, the first one I'm going to remember is the volume. So a volume of a box, length by width by how tall it is. So the area of each rectangle and its h tall of them. So stack each of these, and now you have h areas of a rectangle. And we could also find the surface area of this. I'm going to use a little bit of coloring here. Okay, this face in the front, there's another one in the back. So the front and the back, there are two. This is a rectangle, and this is a length by height rectangle. So there are 2 length by heights plus 2, let's go top. The top and the bottom are LW, length by width, like that, just on top and on bottom. So 2 length by widths plus 2 on the side here. Okay, so these 2 of these blue sides, and that is a rectangle that is width by height. So 2 width by height rectangles to cover the entire area along the surface, the sides of the box. A triangle. Okay. When I think about formulas for triangles, I think of actually 2 different triangles. The first triangle I think of has no particular known relationship between the 3 except for that they meet. A, B, and C. I'm going to call the sides A, B, and C. And I'm going to call how tall it is, the height of this triangle. Immediately, the distance around the outside of this is just A plus B plus C. But we can certainly find the coverage of the interior of this. Now, in order to write down the area of a rectangle's formula, I would imagine 2 of these flipped. That's supposed to be an equal triangle, just flipped up. And then if you were to chop this off, that's supposed to match up and move over here, and it would create a triangle that was B in length and H in height. Okay, so the area of the green would be half. So let's see, 1/2 base times the height. And if you're not quite seeing it, it's like this little triangle would be moved over here. so that we would chop this part off, and this would still be of length B because that distance went over here, and this would be H tall. So this entire rectangle and our green area, which got cut, is now half of that. Okay, so just to kind of talk about where that formula comes from. And so area is half of the rectangle base times height. And then we have this other specific triangle, a right triangle. And I'm thinking that the majority of you know a special formula for this triangle too. It was the Pythagorean theorem. A squared plus B squared equals C squared. But remember that that only works if the triangle has a right angle in it. So it's very, very specific to right angle triangles. Okay, circles. Okay, here's my circle. I'll call this radius R, and I'll call that C. The perimeter, or the distance around, is now referenced as C for circumference. And that has a formula of 2 pi times the radius. And I'm not going to explain where this comes from, but you could definitely Google it. And then, just because that's not the point of this topic, but I do want you to recall all of these. And the area, or the coverage on the interior of this shape, is pi r squared. Okay. And cylinder. Okay, so let's draw best we can. Cylinder. Okay, here's my cylinder. And the top is a circle. It'll have a radius r, and let's call it h tall, so it'll have a height. And a couple of formulas for it is the volume of it is h stacked circles, all of area pi r squared. So the volume is pi r squared by h, because there's h of them. And the surface area is, let's see, okay. When I'm in the classroom, I always do this demonstration where I take my paper and I turn it into a cylinder. So if you were to take your paper and just go ahead and loop it around, then it really makes a cylinder, the top of which is a circle, the bottom of which is a circle. And if you were to cut it, so mine is already cut, if you were to cut the cylinder and open it, so open your cylinder up to get that side area, then this is the height of that cylinder. Okay, so this dimension is the height of the cylinder, and the other dimension, so remember the area of a rectangle is length by width, is around this circle right here. But that's the circumference of a circle. So the length around this is the same dimensions as if I cut it open, as this right here was the circumference of a circle. So its length is the circumference of a circle, and its width was the height. So around the skin around the outside of the cylinder is the circumference, 2 pi r. So the circumference, that's the length, by the width, and that was the height. Okay, but then in addition to that, we have the two circles, one on top and one on bottom. Whoop. So in the surface area, we need to include these circles on top and bottom. So there are two areas of circles, 2 pi r squareds. Okay. And now a sphere, it got cut off by this thing. Whatever, I'll draw it down here. Okay, here is how I draw myself a sphere. Okay. Start with a circle, and then I try to make it 3D by drawing these arcs. A sphere has a volume of 4/3 pi r cubed, and it has a surface area of 4 pi r squared. And again, if you want to know where those come from, go ahead and Google it. Okay, now I'm going to keep these formulas handy because in this next one, classify the measurement, in this example, we're going to use these. So for each calculation shown, decide if it computes area or volume. Then decide the shape and decide how many or what portion of the shape is being considered. So when I see this, I'm like, oh, I got that. That is clearly the area of a rectangle, a length by a width. It perfectly matches this formula, and I can actually draw it. So decide what shape it is. I'm deciding this because it matches this formula. And my image will look like, okay, so my image will look like, what, 7 meters and 6 meters, and this is the area. Okay, so decide if it computes area. I've decided that this formula, or this matches this formula for the area of a rectangle. Decide what shape it is. Done. Decide how many or what portion of the shape. This is a whole rectangle. Area of a whole rectangle. Now I want you to notice it did not ask me to actually compute this, so I'm moving on. I have satisfied. This is more about looking at this computation and matching it to a formula and matching it to the shape. So this is the area of a whole rectangle, and even though it didn't tell me that, I know that just by it's like an inference I made. Here's an example, and I'm saying, oh, well, it's probably this. Okay, and now I see 3 feet by 5 feet by 10 feet, and I look, that looks a lot like this. 3 feet by, what did it say? 5 feet by 10 feet, length, width, height. So I'm thinking it's a rectangular prism. Okay, so let's jot that down. Decide if it's computing volume or area. Volume, length, width, height. Okay, so here is my image. And I don't know, this looks like it would be 10 feet. This looks like it would be 3 feet. This looks like it would be 5 feet. Volume of a whole rectangular prism, shoebox. All right, let's see. Ooh, pi and then something cubed divided by 3. Okay, pi. It's got a pi in it, so I'm going to start there. No pi, no pi, no pi, 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 and pi. Okay, so it's got some kind of a circular reference to it. Let's see. The next thing I'm going to look at, ooh, a cube. And then I'm going to think back, and we had said here that area is in squares, volume is in cubes. So, right on. I'm thinking I'm not a 2D shape because I see the cube. So it's either a volume of a cylinder, pi r squared height, or it is the volume of a sphere where it's 4/3 of pi r cubed. Well, I look back, I see a pi, I see a thing cubed, and I see a 3. So I'm thinking, okay, up here I did A equals L by W. Here I did V equals L by W by H. And here I'm thinking that there's a cube and there's a third in it. So I'm thinking this is the one. But this happened in my mind that 4/3 pi r cubed could be rewritten as 4 pi r cubed and take a third of that. Okay, so these are equivalent, and it looks like they rewrote it to look like that. Okay, so we have a sphere, and I'll draw that. Okay, so we're looking at a sphere, and I know, I'm going to write this down here, that the volume is 4 pi and r cubed. I don't know why I put that in parentheses. It seems silly. I think I saw parentheses there and just imitated. Okay, a third of that. Right. It looks like r is the 4 inches. So 4 inches cubed, and there's the pi. Here's the third of it, but we don't have we don't have all 4. I see, so we just have a portion of it. It needs 4 of these in order to create an entire sphere, so we just have a quarter. 1/4 of the volume of a sphere. Oopsie. Yep, I just wrote a backwards P. 1/4 of the volume of a sphere. And that's because it didn't have this 4. There are 4 of these. It just had 1. Okay, so here I would like to mention R is 4 inches, and it was missing this 4 right here, and instead of there being 4 of them, there was just 1 of them. Okay, so it just had a quarter of it. So it's the quarter of the volume of a sphere here. Ooh. The next one has pi's in it. Oh, I see 2 formulas. Ooh, boy. Okay, here we go. Right. Well, we just looked at this formula, 4 pi r cubed, a third of that. So this is yet another way to rewrite the same volume of a sphere formula. So here, this part is complete because it has the 4 as well. So I'm seeing this 4/3 pi r cubed, or 4 pi r cubed thirds, or how is it written here? 4 pi thirds r cubed. Whatever, it's the volume, but it's 2 of them. So immediately I know that we have 2 complete volumes of spheres and more. This, okay, it's got a pi in it, so I'm going down to the bottom here with all of these pi's. And let's see, it has no cubes, but it does have a square and then another dimension. Pi something squared in another dimension. Not this. Pi something squared, no extra dimension. Pi something squared, the extra dimension. There it is. Okay, so volume of a cylinder. Okay, so this is actually, cylinder. So 2 complete volumes of spheres and 1 whole cylinder. There's only one L in cylinder. Yep. Okay, so what, it's like a barbell, dumbbell with spheres instead of plates. So I don't know, something of the sort, like wee. Yeah? 2 complete volumes of spheres and 1 whole cylinder. Got it. Let's match this one. These also have pies, but I'm noticing there's no cubes. Okay, this one has a pie and then something squared. And it has 2 of them. So it has pi something squared, and it could be this. It could be the volume of a cylinder where the height is 2, or it could be 2 circles. It could be 2 pi something squared. So I'm thinking it could match this and it could match that. It doesn't, it could be half of this. It could be half of the surface area, because instead of 4 it would be 2 then. A pi and something squared. So could be 2 circles area, could be a volume of a cylinder where the height is 2, or it could be half of the surface area of a sphere. So I'm not quite sure yet. So this, I'm thinking, could go some different ways. So now I need to look at this to find out, am I even dealing with area or am I dealing with volume? Okay, here we have 2 pi, and then we have a meter by a meter. That's a square meter. So let's see. We have a 2, a pi, a dimension by a dimension. Ooh. Maybe we're looking at this. A 2, a pi, a dimension, and another dimension, plus, okay, now I'm going to look back. 2 pi, some dimension squared. Ooh la la, that is a perfect match for the surface area of a cylinder. All right, so this all together, so this wasn't separate shapes. Well, kind of separate shapes. This was what? This was the 2 circles plus the skin of the cylinder. So, okay. Looks like we have 1 whole surface area. I'm going to write this down. What was our surface area? 2 pi, I'm going to write it as 2 pi r squared. So the radius here would be 1.5 meters plus, and the formula said 2 pi r times h. 2 pi r times h. So the radius is 1.5 and the height is 3. Got it. I like to make these match just so that I can use them as reference later. Okay, so 1 whole surface area of a cylinder. A cylinder with a radius of 1.5 meters and a height of 3 meters. Up here, just so that we go back and we're pretty thorough, this was the volume of a sphere was 4 pi thirds times r cubed, and the volume of a cylinder was, let's see, pi r squared by h. Okay. Just so that we jot down how we had paired up and matched up the formulas. Okay, half of a 10 by 8 plus a 10 squared. Okay, there are no pies, so I feel like I'm out of circle land. We do have a half, maybe this is a half of a base times a height, so an area of a triangle, and then plus, there are none of those here. But we have to remember something. Okay, so I'm going to tack this on. Let's suppose this rectangle had been a square. So special case here, so we had two triangles, maybe we could have two separate rectangles. One of it which looked like this. That does not even look like a square to me. Okay, too wide or too lengthy. Okay, where the lengths and the widths were all equal, then the area of this thing, so this is a special case, yes? The area would be length by length, or length squared, or a lot of books called the side squared for the square. And the perimeter here would be add L plus L plus L plus L, or add L 4 times, or 4 L's. Okay, so we didn't have one that matched this, but I'm looking at this and in my mind, you might be like, how did she figure that out? In my mind, what I did is I treated this like a 10 by 10. So I rewrote what was happening. I rewrote this as 1/2 a 10-foot by 18-footer. So a triangle, half of a base by height, plus, and then I rewrote this as 10 feet by 10 feet. So I treated that like a rectangle, but I broke it apart. Instead of writing it with the square, I wrote it out. Okay, so I'm really thinking we have a 10 by 10 rectangle, also known as a square, and we have a triangle. 1/2, the base is 10, the height is 18. Yeah? Got it. Okay, so 1 whole triangle area and a whole squares area. Okay. And what I was thinking was that this looks a lot like 1/2 base times height, and this looks a lot like area equals length by width. Okay, so I took what had been done and I tried to match it up with the formulas that I know. Okay, so that's why that reference sheet is pretty handy. Now let's talk about that multiplication of units, because we just did it a couple of times and I just broke it up a little bit. So here, this looks like the area of a rectangle. It's a 4-footer by 3-foot, which when we multiply 4 by 3, we get 12. But this is the area, and remember that area is in squares. It's the interior coverage, yeah? Squares. So a 4-foot by 3-foot area is 12 square feet, or feet by feet is square feet. Okay, so now we have 4 square feet by 3 feet. Okay, so when this is written out, this would be 12 foot by foot to create square feet. Here we have foot by foot by foot. So in this particular instance, I'm going to write it out over here too. We have square feet, which is feet by feet, and then times another foot, which is now cubes. So this is actually a volume of I don't know, maybe a square with the height of 3. So 12 cubic feet. Because now we have square feet, or feet by feet, and then by another height of 3 feet. So now we look at this where it's very abstract and vague, and then remind ourselves that X could represent units or X could represent a numerical value. But even if it's the same numerical value here, we're multiplying them, and something like if X represented 2, this would actually be 4 times 2 times 3 times 2. So even in that case, there would still be a 2 by 2 in here. So here, 4 x's by 3 x's is 12x squared. Or if you prefer to rearrange this, 4 by 3 by x by x. Yeah? 12x squareds. And then it doesn't matter if you're treating it like units, like a foot by foot to get a square foot, or you're treating it like a numerical value, like 2. This is 12 2 by 2s. That'll still work. And then this is very similar. This is going to be 12 x squared by x will be treated like feet squared by feet to make cubic feet. 12x cubes. Or, if you preferred to write it out, 4 by 3, x. Yeah? Okay. A few remarks to summarize everything or cap it all together is this. Okay. Now, I want you to notice that feet by feet is square feet. Having to do with area. And feet by feet by feet, that's feet cubed, cubic feet, having to do with volume. The space inside, or how much is inside an object, and we can only combine like terms. So my last remark, we can only combine, and when I say that, I mean add or subtract, like units. Okay, for instance, feet plus square feet doesn't make sense. Okay, this is a perimeter or a length, and this is squares, and we, if we're going to have units, we don't add feet plus squares. Okay, that's a totally different thing here. But we can, if we need to, add areas plus areas, because we actually do that quite often. More square feet. Okay, so in the context here, we don't really do linear feet plus square feet, but we do square feet plus square feet. Some area plus some more area is more square feet. Okay, so let's just summarize this a little bit, what we just learned. We computed perimeters, areas, and volumes, and we really paid very close attention to the units of perimeters, areas, and volumes, because it all really stems back to the fact that these give us a clue as to what we're computing and how we're computing it. And these also give us a clue about what we're computing and how we computed it. That whiteout's driving me nuts. Okay, and that is, for this section, all about geometric measurements. Keep your units, please.